Welcome everybody, welcome. Today we are going to be talking about the next section in Unit 2, which is going to be 2.3, Solving Absolute Value Inequalities. Now, absolute value inequalities are relatively similar to actually just solving regular absolute value equations. As many of you have probably already guessed, the difference lies in that one word, inequalities. So instead of being equations, where it's an equal sign, we're going to be using inequalities, which has the less than, greater than or equal to, less than or equal to. So we're going to be working with those four symbols instead of the equal sign. Let's go ahead, hop right into it. You're going to notice just how similar it is to solving regular absolute value equations. So, first method we're going to talk about today is, as always, the graphical method. Now, just like before, you can choose to either do this through Desmos, or you could choose to do it on your graphing calculator, whichever one works better for you. Personally, since I'm here at home at my home setup, I'm going to be using Desmos. That way I don't have to try to figure out where to pull a calculator from. So, the equation we are going to use as an example today is going to be the absolute value of x plus 1 minus 5 is less than 3. So, let's go ahead, hop over to Desmos. And in Desmos, we can just grab our graphing calculator. And over here, we just type in the equation that we are graphing. So absolute value of x plus 1 minus 5. And we are going to then graph y equals 3 as a second equation. Now, since we are looking at less than, here, I'm going to show you a couple things here. First of all, what happens if we just plug in the whole thing at once? So absolute value of x plus 1 minus 5 is less than 3. So you can do this, and then it shows us these vertical lines here. In this case, they're in green. Notice that the vertical lines are dotted, so that tells us it doesn't include these points. Dotted on both sides. If it had been less than or equal to, notice that now those dotted green lines are now solid. But all we're really looking for is these two endpoints. So you can see here the endpoint is negative 9, 3 and 7, 3. So these are the 2 points where it intersects. So step 1. Graph both the left and the right side, just like before. I recommend graphing them separately so you can actually see the two graphs, but then on Desmos, if you graph it together after that, not only do you get to see both graphs, but it helps you visualize what the solution is. From there, you're going to mark your two intersections like I just did, and just like before, unlike before, we need to identify if we're going to be talking above or below usually I'd look at it as above or below the solid line, the horizontal solid line. So looking at our graph, since we have less than, the equation is less than the line, we're looking for where the line, in this case red, the equation, is less than or lower than the solid line that we graphed. In this case, that happens between these 2 points. So our solution then becomes everything from negative 9 to 7. And we have a lot of different ways we can write that. The first way we can write it is negative 9 is less than x is less than 7. So you can see this blue one gives us the exact same symbol as the green one. And that's one way that you can check what we've got. Because if we reverse these and we make this as greater than and this is less than, well, now you can see there's just this line here, or this inequality, and it tells you that they both have to go the same way, and that's just because that's how inequalities work. This doesn't work. But what if we went like this? Well, now it's still not there. You guys can see that it's not there. That's because the only way they can go is in the logical way that makes sense. Another way we can write negative 9 is less than x is less than 7 would be using our interval notation. Now you can see in this case it doesn't actually show you anything. That's because Desmos only recognizes that as a dot. So on here you can't graph it that way, but that is one way we can graph it. And then the final way would be set notation. So the set of all numbers x such that -9 is less than x is less than 7. So these are the three notations that we have used in class. And that bar needs to not be there. Unfortunately, Desmos doesn't like the fact that I've used this bar because it thinks I'm looking for an absolute value, so it's trying to close the bar. Any one of these three are correct. The only thing you have to be careful with, just like before, is making sure that you know which one it's asking for. So if the question asks for the answer in a specific way, make sure you give it that answer in that method. So if it asks for inequality notation, if it asks for interval notation, or if it asks for set notation, make sure you're giving it the one that it wants. Now, obviously, as always, we have another method of solving. We could try to solve these algebraically. If we want to do so, we're going to have to, just like before, isolate the absolute value, get it all by itself. That's going to be PEMDAS backwards. Split our equation into two parts. Well, I say two parts, but you'll see sometimes there's actually going to be more than two. And finally, we just solve for our x values. In this example, we're going to use the absolute value of x plus 1 minus 7 is less than or equal to 4. So, as always, PEMDAS. We start with PEMDAS backwards, addition and subtraction, outside of the parentheses. I see minus 7. So, I'm going to add 7 to both sides of our equation. If I add 7 to 4, I get 11. So the absolute value of x plus 1 is less than or equal to 11. Well, I've done step 1 now. I have isolated my absolute value. Now that it's alone, I have to do step 2, split it into parts. Now, notice my absolute value, my inequality sign is less than. In this case, specifically, it's less than or equal to. But because it's less than, I can split this into parts in a different way than we're used to. I'm going to take that 11 and I'm going to pop it over to the other side of the inequality as a negative 11. And I'm just going to rewrite the inequality. So now instead of having 2 halves, I actually have 3 parts all written as a whole. Now what's really cool about this is now I've gotten rid of the absolute value sign, I can just finish solving the equation. The only thing that I have is addition or subtraction. I have plus 1. The opposite is minus 1. So if I do that to the middle, I don't just have to do it to both sides, because there's not 2 sides. There's 3 parts. So I'm going to subtract 1 from all 3 parts. Negative 11 minus 1 is negative 12, and 11 minus 1 is 10. So my answer actually ends up being negative 12 is less than or equal to x is less than or equal to 10. Notice that because my original symbol was equal to, less than or equal to, when I brought it over here, I kept that or equal to. So you'll always look towards your first symbol to decide whether or not your second one will have the equal to sign. However, they don't always work this way. If this symbol is pointing the other direction, like it is in this problem, we're going to have to do something a little differently. So let's go ahead and solve this one. You may recognize it from before. The only difference is I've traded the equal sign for a greater than sign. So just as before, a plus 1 is we're going to subtract from both sides, giving us 24. So I have 4 times the absolute value of 4x minus 2 is greater than 24. Moving backwards through PEMDAS, I now look for multiplication and division. I have times 4 on the outside. Upon dividing by 4, I get 6. So the absolute value of x minus 2 is greater than 6. I have now isolated my absolute value, And I know this says split it into 2 halves, but really we're splitting it into 2 problems. Be very careful here though. When I take this 6 and split the problem in 2, notice what happened to that greater than sign. On the side that became a -6, that greater than sign became a less than sign. The reason that happened is because effectively what we're doing is we're multiplying the right side of the equation by -1, which flips the sign. As you're solving from here, don't forget also that if you divide or multiply by a negative number at any time, you're also going to have to flip that sign. It's very important to remember, and if you don't do it, you will end up with the wrong answer. So let's go ahead and solve the rest of our problem. I have I'm subtracting 2, so I add 2. -6 plus 2 is -4. I'm multiplying by 4, so I divide, and I get x is less than -1. Doing the same thing to the other part of the equation, adding 2 to both sides gives me 8. Dividing by 4 gives me 2. So my 2 answers are either x is less than -1 or x is greater than 2. So hopefully you guys see that there are multiple ways to look at these absolute value inequalities. I strongly urge the graphical method for these because it is so much easier to deal with than trying to remember, like, do I have to flip the sign? Can I write it all as one string? Do I have to write it as 2 separate ones? Much easier to simply graph it on Desmos or your calculator, figure out if you're looking for where the absolute value sign is above the horizontal line or below. That's going to be greater than for above or less than for below. If you get those sorted out, you guys are going to be more than fine with this. So with that, you should have all the information you need to do your HRW assignment, which is going to be 2.3 solving absolute value inequalities. And like I said, that one's going to be on HRW. Good luck, guys.